Welcome. In the last couple of videos, we talked about various components inside of a computer, what they do, how they interact with one another, and we also talked about how information is represented by using sequence of bits, which are alternations of electrical current that are transferred from a source to a receiver through a wire. And in all these videos, we have not talked about something that is very important as a key component for a computer to work, and that is us, the humans. Where do we play a part in all of this? How do we tell a computer what to do? Over the time of these videos, I've continuously used the operation 5 plus 7. But how exactly do we tell the computer to process this operation? So in this video, we're going to be talking about programming languages, which is the mechanism that we humans use in order to tell a computer what to do. So let's get started. So suppose that I have the processor here. So in order for the computer to understand 5 plus 7, we know that we have to convert it to its binary form. So we know that 5 is 101. And we also know that every piece of information has to be at least 8 bits long, or a byte. So therefore we put 5 zeros right in front of it. We repeat the same with 7, which will be 3 ones. And we add also 5 sevens in front of it. Right? Now, we also need to convert the plus sign. Now, we said that for symbols, we have to pick some kind of representation also as a byte. So let's suppose that the plus, the plus operation is going to be 8 ones. I'm just making that up, but let's assume that it's 8 ones. So I will have 1, 2, 3, 4, 5, 6, 7, 8. So what exactly happened here? We went from having a human thought, right? Human thought. Imagine, I'm thinking to do 5 plus 7. And I translated this human thought to a binary sequence in order for the CPU to understand. Then all these bits get transferred to the CPU by a couple of wires which get connected to the CPU. The CPU then computes this solution, and the solution then comes out, let's say, from over here, which we get, let's say, 12. Let's say it comes from here. So this sequence that you have here is called an instruction. And this instruction has a binary form. In this case, we have these 3 bytes. The CPU understands tons of instructions that the engineers that created this CPU have defined. In other words, the CPU is able to handle a set of instructions. And this set of instructions is how we are able to talk to the CPU. And this language that we can use to talk to the CPU is called the machine code. So, if we want to talk to a computer, the first thing that we have to think of is, I need to convert my human thought into machine code. In this case, I need to convert 5 plus 7 into this sequence of bits, 0, 0, 0, 1, and so on. However, that is way too tedious. Can you imagine you having to do that with everything you want a computer to do? It would take so long. You might as well just do it yourself. You wouldn't need a computer to do these things. Fortunately, someone out there thought, well, I have all these instructions in their binary form. Why don't I give them names? Why don't I give a name to every instruction that the CPU can do? And then I have the programmer, or I have the human, use the name of the instruction, and then I write a piece of software that will convert this instruction to its binary form. For example, so let's suppose that the first 8 bits, which represent the 5, why don't I give it the name 5? Right? That's very convenient. I will name it 5. Then the next 8 bits, I would give it the name add. And the last 8 bits, which is a 7, I give it the name 7. So now, for me, instead of going from human thought to machine code, what I can do is I can write my instructions in this form, and then this other software that the engineers of the CPU created, they go and convert it to machine code. The name of this intermediary language is called assembly language. So the point of this assembly language is that it allows us to have a programming language that is human readable. If we did not have this, then we would have to tell the computer what to do, and we would first have to learn how to talk in machine code. Well, that would be way too tedious if we have to do that just with nothing but zeros and ones. So therefore, someone created this assembly language as a language that we use in order to write instructions for the computer to execute. And then these instructions, before they're handed over to the CPU, they get converted to machine code, which is their binary representation. Now, with that being said, the assembly language is designed by the engineers who created the CPU. So if you have an Intel CPU, the assembly language could be slightly different than the AMD CPU. And so basically, whatever CPU you are trying to program, you will have to learn and understand that assembly language. Of course, there are standards, so most of these instructions, let's say the add instruction, most likely looks the same in both AMD and Intel. This is to make it easier for us. So, machine code and assembly language, they're known as low-level languages. They are called low-level because they're closest to the hardware. So with the assembly language alone, we're able to do whatever we want. However, as life moved on, we now have way more difficult applications. We write code for many different things out there, data processing, we have graphics. There's just so much out there that learning assembly and doing everything in assembly, it becomes a little difficult to manage. The code in assembly isn't very clear. It isn't very clean. Let me give you an example. Let's suppose that I wanted to do the following. In order for me to do something like this in assembly, I would have something like 5 add 7, and then the result of that would have to be subtracted. Let's say if subtraction was SUB 8, and then the result of that, I will have to add again, and I will add 3. And then the result of that, I will add again 5. Notice I'm using R to indicate that I'm using the previous result. In order to do one operation like this, I have used this many instructions, 4 instructions. That's quite tedious. And now this gets converted to a bunch of bits, which then get transferred to the CPU and get executed in order, right? Because I have to get the result from the first one in order to use it on the second one, and so on. Well, wouldn't it be nice if we had a programming language where we could just simply write this? Why do I have to do all of that? So someone out there said, you know what? We can actually create something where we can go from here to here, right? I mean, every time there's a plus, I just put an add in between the first part and the second part. And when there is a minus, then I put a subtraction in between the first part, which in this case would be this whole 5 plus 7, and the second part, which will be the 8. And you continue to do that. There is a pattern. So someone out there said, why don't we make a language where we're able to do this? That way make things way more easier. And this is where C++ comes in. Okay, so let's go back to our first example. C++, the language that we're using to learn how to program in this video series, is a language that sits right above assembly language. And the cool thing about C++ or any other language like Python, Java, and so forth, is that they are even more human readable than something like assembly. And more importantly, they offer you a lot of other tools, programming tools, to help us manage code, which we're going to learn as we go through this video series. So something like C++, if I wanted to do 5 plus 7 in C++, I simply have to do 5 plus 7. Now, if you look at all of these 3 methods, you have 1, 2, and 3. Which one looks more convenient? The first one. And this is just with a simple instruction, such as addition. Imagine doing this with many other things like multiplications, and you're doing tons of other operations, and you're handling a bunch of data. It adds up. And your assembly code can get very big in comparison to your C++ code or in comparison to any other programming language code. Languages like C++, they are called high-level languages. What's interesting about these high-level languages is that they have to also get converted to machine code. So what's actually happening here is that your human thought, you as you are trying to solve a problem using a programming language, is that you convert it to some kind of programming language, in this case C++, and then once you're done, C++ gets converted to assembly language, which then the assembly language gets converted to machine code. The process for C++ becoming assembly language is called compilation. So we write C++ code and it gets compiled. The assembly language, which I misspelled here, and I forgot the L, then gets converted to machine code by a process called assembly, which lastly gets executed by the CPU. Now, generally speaking, we do not need the assembly language when we compile C++. So for the most part, what actually happens is the compilation process skips this step, and we go directly from C++ to machine code in the compilation process. Should you ever program in assembly language? Well, sure, if you ever have to talk directly to the CPU. And you might also wonder, well, if you program in assembly language, wouldn't that be faster since you skip the translation process? In theory, yes, this is correct. However, these compilers, these C++ compilers, they have been around for a very long time. And the argument here is that it is very likely that the compiler can change the C++ code to assembly much more efficiently than you can probably program in assembly. In other words, I'm saying that it is very likely that these compilers program in assembly better than we do. Now, before we wrap up the video, let me just quickly and briefly talk about the operating system. It is very likely that you're watching this video through some kind of mobile device, a laptop, or a desktop. And in all of these devices, there is an operating system. And this operating system gives you a lot of tools in order for you to use the computer. In fact, you don't really have to program anything in order to watch this YouTube video. You open your browser, you go to YouTube, and then you click on the video and you watch it. You don't really program and say, okay, go and, let me do this with C++ in order to go and request the video from the internet. And then let me write this code in order to actually be able to see the video. You don't do any of that stuff. Same thing with your mouse. You do not actually write code to use your mouse. You just plug it and you use it. A lot of these things, you're able to do them without even thinking about programming is because someone out there already wrote code in order to handle these features. So the operating system, think of it as a set of managers. It manages the memory. It manages all the files that you have in your system. It manages how your software that you're running on your computer is able to use the CPU to execute its instructions. It also manages all the devices that you connect into your computer, such as some USB, a mouse, or a keyboard. All of this stuff was written by someone using a programming language, which then got converted to machine code, and now the computer is able to understand and do all the things it was told to do. So, quick recap. We have a processor which was created by some engineers, and this processor has a set of instructions called the instruction set. And these instructions is all the things that the CPU can do. And the format and how we tell it to do these things is called machine code. The machine code, however, is not human readable. We do not understand it. It's not easy for us to see it and know what it's doing. So therefore, another language called assembly language was created in order for us, as the programmers, to tell the computer what to do. The assembly language gets converted to machine code, which is then passed on to the CPU for the CPU to execute. But even with assembly language, there are certain difficulties and challenges that we face. So therefore, other programming languages that we know as high-level languages like C++ were created to make these things easier for us and provide programming tools. So we humans transfer our human thought in a way, the things that we would like the computer to do, into C++ code. And the C++ code then gets compiled into machine code, which then is executed by the computer to handle. If you have any questions, feel free to leave a comment below. If there's any concerns also, leave a comment below. I hope you found this video useful. If you're new to these videos, make sure to check out the channel. And if you don't mind, leave a like. Be safe and peace out.